Today we're going to review substitution. What you should know how to do so far this unit, number one, is solve the system by graphing. So let's do that first. You are in charge of ordering baseball helmets for a baseball team. There are two companies that you are looking at. Hard Heads charges a one-time delivery fee of $255 and $50, and then they charge $50 a helmet. Baseball Guy charges $70 a helmet and a one-time fee of $75. Write a system of equations to represent this information. All right, so first let's write y equals, and for the first company it's $255 for the delivery plus $50 per helmet. And for Baseball Guys it is a delivery fee of $75, but they charge $70 per helmet. Which company is cheaper at first? Well, you can see that Baseball Guys starts with $75 first, so they're cheaper initially. How many helmets need to be purchased so both companies charge the same amount? All right, so let's do this by graphing. We could also do it by substitution, but by graphing, let's type this in and find the point of intersection. So I'm going to open a graph page. I'm going to type in the first equation, 255 plus 50x. Hit enter. And let's type in the second one, and then we'll change the window on our graph. Oops. So 75 plus 70x, so I'll hit tab, and we'll do 75 plus 70x. Okay, let's change our window, so I'm going to go to Menu, Window, Zoom, and let's do Zoom Fit, see what happens. And we can see where these cross. Let me move my calculator over here. So Baseball Guys, the one in red was the second one I typed in. You can see it's initially cheaper at first until they meet at some point, and then it becomes more expensive because they're $70 a helmet versus the $50. But since the first company starts at $255, they're expensive at first until they're tied. But then since the the helmets are only $50 a helmet, eventually they become less. So let's analyze our graph here. Let's find this point of intersection. Here it is. So at 9 helmets, they both cost $705. So let's write that down. At 9 helmets, they both cost $705. And then after that, Baseball Guys becomes more expensive because they're $70 a helmet. We could also do this by substitution. Let's see if another example of that. Yeah, we do. All right, so we also could have set them equal and have seen when they were tied. Let's do that with this example, though. We have y equals 2x minus 17 and y equals x minus 10. Let's set them equal and solve. So when does 2x minus 17 equal x minus 10? I'm going to add 17 to each side. I'm going to get 2x equals x, and then we have plus 7. I'll subtract x from each side. So we have x, 1x equals 7. And again, we're looking for the point of intersection. Where do the lines cross? So I need the y value. So you can pick either equation and plug in. I'm just going to pick this second equation. We have y equals 7 minus 10. And I get y equals negative 3. So these two lines, they do cross, and they cross at the point 7, negative 3. And we can check our answer by plugging into the first equation and seeing if both sides are equal. So let's do that. Y equals 2 times 7 minus 17. Oh, sorry. Y equals, I plugged in wrong. All right, so the y value is negative 3. So negative 3, does that equal 2 times 7 minus 17? And this is 14. 14 minus 17 is negative 3. So you can check by plugging in. All right, we also looked at can you solve a system by plugging one variable in for another. So you do this when only one variable is by itself. So if x is by itself or y is by itself in just one of the equations, you use this type of substitution. So I'm going to take this 1 plus 5y and totally replace it in for the x. So we have 9y minus, and then use parentheses when you plug in. Let me use a different color too. So we're going to plug in, instead of x, I'm going to write what x equals, which is 1 plus 5y. And this equals negative 9. And then we're going to distribute as the next step. So we get 9y minus 1 minus 5y equals negative 9. Since the y's are on the same side, I'll combine like terms. 9y and minus 5y are 4y. Minus 1 equals negative 9. Add 1 to each side. We get 4y equals negative 8. Divide by 4, So we get y equals negative 2. All right, so these two lines, they intersect, but we need the x value, so let's plug into the second equation where x is already by itself. X equals 1 plus 5y, but we know y is negative 2, so we're going to use parentheses when you plug in. So we get x equals 1 minus 10, so x equals negative 9. So these two lines, they do meet, and they meet at the point negative 9, negative 2. And you can check your answer by plugging in. We could do 9 times negative 2 minus 9 and see if that equals negative 9. And if it does, we did it right. Okay, let's look at the last one, number 4. I'm going to clear this. All right, so this one again, only y is by itself, but it's not by itself here. So we're going to plug in. This 30 minus 5x, we're going to completely replace this y right here. So here's what it looks like. 3x plus 4. But instead of the y, you plug in 30 minus 5y, or 5x, and that equals 52. Now we're going to solve, so we have 3x plus, let's distribute, 4 times 30 is 120, 4 times negative 5x is negative 20x. This equals 52. Let's combine like terms here because the x's are on the same side, so we get negative 17x plus 120 equals 52. We're going to subtract 120 from each side. We get negative 17x equals 52 minus 120 is negative 68. We'll divide each side by negative 17. So we get x equals 4. So these two lines, they do cross at x equals 4, but we need the y value, so plug into y right here. Y equals 30 minus 5x, but x is 4. So we get 30 minus 20. So we have y equals 10. So these two lines, they do cross at 410. And again, you can plug back into the original equation. 3 times 4 plus 4 times 10, does it equal 52? And it does. So you can check your answer.